How's it going? Good. Can you all hear me? Great. See, the music stops and we start right on time. That's awesome. All right. So my name is Deborah Chen, and I'm a program manager on the Azure Cosmos DB team, where I work on the developer experience. So this covers everything from the SDK experience, the portal, and our new notebook features. How many folks, by the way, here are developers? OK, awesome. The advertising worked. You've all come to the right place. Today's talk is about what you need to know as a developer if you're developing on Cosmos DB. So whether you're from the beginning, you're just getting started, even evaluating Cosmos DB, maybe you're in the middle of a project where you're just debugging, testing, making sure the code works, or you already have an app running in production and you just want to monitor to make sure it's going all right, we'll have very practical, concrete tips and tricks, best practices for every step of the way that we'll share today. So obviously, there's a ton of stuff to cover. So what I've done is pick the highlights of what I think you should really focus on, get some awareness of. And then for a lot of topics, we have deep dive sessions later this week if you want to get more detail. This is the level set. How many folks here have actually used Cosmos DB? OK, great. How about running it in production? OK, great. So everyone who didn't raise their hands for that will come back a year from now, and then we'll get everyone's hands raised for Cosmos DB and running in production. But hopefully, if you're on your journey way there, you'll learn some tips today that you can take home with you and start implementing as you keep developing. As a quick level set for those who are new to Cosmos DB, let's quickly explain what Cosmos DB is, and then we'll dive in. So Cosmos DB is a database service in Azure. It is a NoSQL or non-relational database, which means that we support many different document or data models, including key value, column family, document, and graph. On top of all of these different data models you can have, we have various APIs or interfaces you can use to access your data. Underpinning all of these APIs and data types are our core features, value props around global distribution, scalability, low latency, tunable consistency, and SLAs. So for each of these features, we'll go through what do you actually have to know about and think about, and how does it impact you when you're building and developing a solution on Cosmos DB. All right, so I figured for this talk, it's always easiest to learn in the context of a real-world example. So I've taken a scenario that's actually a simplified version of some of our real-world customer scenarios, where we are now all going to be part of a logistics company called Contosa Logistics. And we have a bunch of vehicles that deliver consignments or orders to customers. This is actually based on a couple real-world customer case studies we have. So we have a bunch of vehicles on the road, and we're developing a new app, and we want to do two different things. The first thing we want to do is we want to track our vehicle and delivery status in real time. And in order to do that, if we have a bunch of vehicle telemetry, we're going to need to ingest it into some service at a very high rate. The next thing we want to do is to build a fleet management web application where we can actually see, as an administrator, a manager, what is the status of all my vehicles, consignments, and packages. So if I need to check something's been delayed or something didn't make it in time, I can quickly go to this one-stop place and view the status of all my trucks on the road. All right, so this is a very simplified architecture. We're going to have data coming in from vehicles. It's going to go to IoT Hub, pass through a function to do some processing of the data, and write it to Cosmos DB. From Cosmos DB, we'll land the data, as well as build a web app that is a view on top of it. For today, we're just going to be focusing on the Cosmos DB components, but know that the other parts of the solution are there as well in this kind of architecture. OK. All right, and luckily for us, our business has already, before we even started developing or building anything, they've already given us a mock-up of exactly what they want and what kind of data they expect to see. So today we'll be building this kind of fleet management application where you'll be able to click on vehicles, look at the various orders, consignments, and trips and deliveries and such inside. So again, just a quick note here. The focus is not necessarily how to build this web app UI or this application. It's if you're going to build this kind of app, in your data access layer that talks to Cosmos DB, what are the things you need to think about to make sure that you set up the Cosmos DB part correctly? All right. Some of you may be wondering to begin with, that's great. This is the Cosmos DB session. We're going to build an app. Should I even be using Cosmos DB for this thing? Right? Am I just using a technology because I like it or it's cool? Right? In general, for all use cases, you should use Cosmos DB if you have one or more of these requirements are true in your application. So the first one is a flexible schema. we support the document data model, or basically JSON, which means that since we don't enforce a schema in Cosmos DB, you can put anything you want in the JSON. So if your application schema changes over time, then you don't have to worry about managing a schema, doing schema migrations, managing your own indexes. Your application can evolve along as your data evolves easily. So good news for us is in our scenario, we have a bunch of IoT sensor data coming in, and the sensor data may change over time. Today we might want these 10 things, maybe tomorrow we want these 8 things. And as we continue ingesting data into our database, we don't want to take down a database to do a schema migration or change a schema. So flexible schema in Cosmos DB is a good fit for us. Okay. Next thing to ask us is, do you need scalability? And in particular, Cosmos DB is really great for write scalability. In our case, we know we're going to need a high number of writes per second because we have thousands of vehicles on the road, and every second they're pushing at least one piece of telemetry to the database. And the good news for us is that Cosmos DB can actually guarantee the throughput for any workload, provided that you configure it correctly. So throughput is number of operations per second. So we can actually tell Cosmos DB, I want an equivalent capacity to say 1,000 writes per second, provision it, guarantee it, and no matter what time of the day or as long as you are under that, we'll be able to support that amount of provision throughput. Okay. Next one is, do you want it to be fast? Now, every database service is going to say that they're a really fast database, but Cosmos DB is actually the only database service in Azure, as well as along all the other cloud providers, to offer an SLA on latency. So we guarantee for any reads and writes of a 1 KB document, so JSON document about 10 properties or so, that it'll finish in less than 10 milliseconds at P99. So if we do this 100 times, 99% of them will finish under 10 milliseconds, which is single-digit millisecond latency for reads and writes. It's fast enough such that in addition to writes, you can even use it as a fast cache for reads. So we've actually had a lot of customers replace their caching solutions with Cosmos DB, since for the key value lookups, it was about similar performance level, but a lot easier to set up and manage. Okay. And finally, do you care about your app always being available? Cosmos DB offers 5 nines of availability with 2+ regions. And does anyone actually know how many minutes of downtime 5 nines is at most a year? Okay, who thinks it's more than 5 minutes? Raise your hand. Okay, who thinks it's less than 5 minutes? Okay, it's actually around 5.26 minutes. So the cool thing is we've actually been in this talk longer than the most amount of time your Cosmos DB possibly could have been down in a year, which is, I think, is pretty cool. So in our case, I would say this is a pretty good use case for Cosmos DB, and you should evaluate, before you just start your app on Cosmos DB, if any of these requirements are true, and consider it as a potential solution. Okay. Next thing I want to do is figure out which API should I use for my application. Now, earlier I told you we have all these APIs, all these data models, too many choices, too hard to make a decision. Our official Cosmos DB guidance is for any new workloads to go with the core SQL API. It'll give you the best developer experience since we actually control both the interface, the service, and the SDK client libraries. So any new feature we have immediately goes into our core SQL API first. There's no SQL server running here. The SQL API just refers to using the SQL query language syntax to write queries over your document or JSON data. Okay. The other APIs are really there for migration. So if you have existing Cassandra, MongoDB table API applications, and you don't want to rewrite your whole data access layer, but you still want to get the benefits of Cosmos DB, you can migrate your data, change your connection string. We understand the wire protocol, and then your app can continue running as normal. But really, these are if you absolutely do not want to write your app and just want to do migration. We also have a Gremlin or a Graph API for graph data. So if you want to learn more about that, come to our booth. We're happy to tell you all about graph database. OK, so let's actually get started and start figuring out how to configure Cosmos DB. Does this work? Yes, OK. Let me zoom in. All right, so the first thing you want to do is create an account. That's pretty straightforward. At the account level, you'll pick which API you want, core SQL API. You'll tune other regions, whether you want particular settings. All of these can be changed later, so I'm not going to worry about them. Just know that the API is going to be at the account level. So account's fine. I already have an account here. And the next thing I'm going to need to do is create a new container to hold my data. So the resource model in Cosmos DB is we've got an account, we've got a bunch of databases. So demo's a database, fleet management's a database, and a bunch of collections or containers. Inside each collection or container is basically a JSON document. So I'll just pick one here. Okay, can all of you see this? Okay, let me zoom in a bit. Okay. Feel free to yell zoom in from the back if things are too small. All right, so JSON document here, and I can have any kind of schema or put really whatever I want here. It really depends on what my application needs. All right, so to hold the data for my application, remember I'm going to be streaming a bunch of IoT data at a high rate. So I'm going to need a container or collection to hold my data. If I go ahead and try to make a new container, I'll see there are some settings it'll ask me. Database, easy. Container name, easy. Partition key, got to put something in here. Throughput, some magic number here, got to put something in here. Right, so sometimes our first instinct is just to put anything we want in the box and then, oh, it should just work. But for us, since we have time here, let's actually go through what is throughput, what is partition key, and figure out for our particular scenario what numbers and values we should actually put in the box in order to set up Cosmos DB in the most optimal way. Okay. So first concept here is request units. How many folks here have actually had to work with request units in Cosmos DB? Okay, and how many are completely new to the concept? Okay, great. So we'll basically explain what it is, and we'll show a demo of how you can use it to scale up and scale down your database. Cosmos DB is different from other databases in that it works on a provisioned throughput model. You tell us the expected capacity or performance, and it's expressed in a unit called request units per second, or RUs per second. So every operation consumes a certain amount of request units because it takes a certain amount of work to some CPU, memory, and IOPS to actually do that operation. Okay? And you tell us exactly how many RUs you need per second, and we'll guarantee and provision that, and then you're set. So if I have 1,000 RUs per second worth of capacity at 1 second, that 1 second, I can consume it. Next second, resets. I get another 1,000, 1,000, 1,000, et cetera. So it's really important to actually provision it correctly for your database or container and decide what is the actual throughput or number of operations you actually need for your database. For us, you can provision at the collection or database level, so what I was showing you just earlier here. And you can also change the RUs programmatically over time with API calls. So the good news is the more capacity you provision, the more it costs, but you can scale down. So if you're scaling down, you'll save a bunch of money that way, and that's actually one of the best practices. So you can change it programmatically with API calls, or if you never want to think about this again, even as much as we love you too, we actually announced a preview of Autopilot on Monday to automatically let you, let the container scale itself based on the usage. So tons of requests coming in, it'll scale up, kind of quiet period, it'll scale down, and it'll basically charge you for the RUs that you are using, that you're provisioned at for the current time based on how it's scaling. Okay, so feel free to try that out if you want to, if you don't want to think about how to manage your throughput. Okay, so in terms of the benchmark to make it a bit more concrete, every operation consumes RUs. The benchmark is for a 1 KB document, takes about 1 RU to read the document. And to write that same 1 KB document takes about sometimes 5 to 7 RUs to do the write. Query really depends on the complexity of the query. If you get a lot of documents back versus a small number, it'll be more RUs. Or if a really complex query, like a bunch of group bys, counts, aggregates, that may consume more RUs as well. And then indexing also affects the RU cost on writes, which we'll talk through later. Okay, pictures, great. Yes, remember these benchmarks because you'll need to know them very soon in the next couple of slides. All right, so now we've kind of got the basic theory. Let's actually apply it to our scenario. So we need to ingest a bunch of data, and let's estimate the RUs we need. All right, so here's the math portion, I promise you. It's a very short part of this talk. All right, so let's say we have 1,000 vehicles on the road, and each vehicle is going to send a new telemetry event, a new document write to the database every second. Okay, so each document will consume some number of RUs. We don't know yet. We'll find out. But if we know that number in that blue magic box, we'll multiply it by 1,000 and then get the total number of RUs per second we need. And that's what we should provision in that box for request units. So now the question is, if we do a write against Cosmos DB, how many RUs does the document consume? All right, so the first question, you can't answer this until you know what the document is. So I'm going to tell you that for our use case, we're going to have a sample telemetry event document that looks like this. Just has some info about the vehicle, the VIN, the state it's in, and just some data about where it is on the road, speed, et cetera. Things you might want to know about a vehicle to track on the road. Okay, so we have that, and now we need to figure out the next missing piece, which is how to actually get the RU charge. So let's do another demo. All right. VM is great. Okay, by the way, the demo Wi-Fi on stage is a lot better than the Wi-Fi out there. So if you all want to be speakers next year and get good Wi-Fi, please sign up for that. All right, so again, so what is our goal? Our goal is to figure out for that telemetry event, how many RUs does it consume to write it to Cosmos DB? Here in Visual Studio, I'm using our new .NET v3 client library SDK. And I'm going to write a demo that's just going to get the RU charge for that document. So assume I'm going to first get my document here. So all this is doing is reading that file from local drive, converting it to JSON so I can have it. Then I'm going to do a create item, which is basically a write of the item. I'm going to give it the event itself, the partition key. We'll tell you more about partitioning later. And then just print out off the response object here, how many request units did it take? All right, and then I'm going to do the same thing for a read as well. So same thing, read, and then print out the RU charge for a read. Now, instead of actually running this against the service, which is going to consume real dollars and money, I'm actually going to use a great tool we have for developers that is the Cosmos DB emulator. So I already have it installed. You can see this blue icon. And it basically emulates the Cosmos DB service on my local environment. So I have it installed locally, but you could also put it in a Docker container on Windows and then use it there if you don't want to actually download it locally. So I'm actually going to use the connection string for the emulator right here. Okay, and it's the local host and then the well-known emulator connection string. So when I run this, this is going to be demo 1. Scenario 0. Okay, I'm going to do the test read and write, and this one says, I wrote the item, consumed about 10 RUs, and I read the item, consumed 1 RUs. So it's really, as a best practice, for every item you're reading and writing, and even your queries, run them using our client libraries or the portal, figure out the RUs, multiply it by the number of operations per second you need, and then you have a very easy way to get the total RUs you need. For folks who didn't like doing any of this math, we also have a handy-dandy Cosmos DB RU calculator, which is just a nice fancy UI on top of this, where if you don't want to spin up the client library, you can actually go ahead and just say how many reads per writes per second you want, what's the size of my document, and if you sign in, you can also get a view where you can upload your own sample JSON and get that same view there. Okay. Okay, so we figured out each document costs 10 RUs to do the write. And here's a math formula again. So 1,000 times 10 is, all right, come on. All right, 10,000 RUs per second. Yeah, sometimes when the answer is like, you don't want to say the thing where it's like, oh, what if I'm wrong? All right, so 10,000 RUs per second. And that's great. Now we know what number to put in the box. And by the way, just for this scenario, we know for hot data coming in, you don't always want to have years and years of hot IoT data in Cosmos DB. So we can actually use a feature called time to live, set it for around 7 days or so. So it'll land in Cosmos DB for 7 days. We can archive it later if we want. That'll give us around 75 GB of data. So 75 GB of data, 10,000 RUs per second, pretty reasonable. Okay, so now we know all about, we need around 10,000 RUs. So now we need to make one more decision, which is, do we want to do Autopilot or do we want to do manual provisioning? So Autopilot is in preview as of Monday. It's really good if you have a bursty, unpredictable workloads. So if you're thinking about your workload and you're saying, oh, you're telling me I have to know how many operations per second, how many reads per second, what the queries are, what the sample documents are, I have no idea, and you're just starting out, you want to get your feet wet, Autopilot's a great thing. You can basically pick the tier you'll be in and scale between 10% of that and the max. So if you're starting a new workload, start at the lowest tier. We'll scale you up and down based on the usage. If you're a little more experienced and you basically know very well what your workload is, you can actually manage the throughput yourself. So you'll say, I want X number of RUs per second, and you can change it programmatically with an Azure function. Maybe it's timer triggered. So a lot of our customers, they have workloads where maybe between the hours of 12 to 1, where everyone's on a lunch break, their website will have a ton of traffic because people like to buy things and read the news. But then other hours of the day, it's pretty quiet. Or other customers where they have, their employees are using their application from 9 to 6 p.m., but after 6 p.m. in the evenings, it's pretty quiet. So they actually timer trigger to scale up and scale down exactly when they know they're going to need higher traffic and higher volume. OK. All right, so now we've decided that we need around 10,000 RUs per second. Let's see what we can actually do to benchmark this, measure performance, and show how we can scale up Cosmos DB to our needs. All right, can you see this? Great. Let me zoom in. OK. So here I have a database and a collection. By the way, collection, container mean the same thing in this context. Collection just means it's documents. If it's a different kind of container, it might be like a table container, a graph container, et cetera. So here I have a collection that is going to store some IoT data coming in. We're going to simulate writing a bunch of data at once. And we've provisioned it to 10,000 RUs per second of throughput, which is what our math and our calculators told us to do. So with that, we should get around 1,000 writes per second. So let me go ahead and run this one. Okay. By the way, to simulate this very high traffic on the website, since we're not going to wait till our cars are actually on the road to test this in production, we're going to use the bulk executor library to just generate synthetic documents. They're going to look something like this, and write them to Cosmos DB in batches. So this one, I'm going to be writing about 30,000 documents in batches of 3. Okay. The bulk executor library is optimized to basically push data to Cosmos DB at a very high rate. So it's also good for bulk imports or bulk delete scenarios. Something that's new in our newer client libraries is we also have the bulk executor mode built in. So if you have already using the latest version of our libraries, you can get the similar functionality there as well. OK, so I'm going to run this. We're going to generate a bunch of data and write it to Cosmos DB. And we're going to actually print out and see how long it takes to import this data with that amount of RUs. So we provisioned 10,000 RUs per second. We actually got a little bit higher than 10,000 RUs per second, which is sometimes the way Cosmos DB works is you provision a certain amount. If you start to go above it, the first one it might let you, but then the next ones it'll rate limit or resource govern you out. So it'll tell the library, please wait a little bit, retry, try again in the next second or the next 10 milliseconds, et cetera, and your request will get through. So this is how we ensure that if you provision 1,000 RUs per second of capacity, for any request that makes it within that bar, it'll get that guaranteed performance that you expect. OK, if I did this batch enough times, see, it's rate limiting me down. If I did enough, it would get to around 10,000 RUs per second. So this is great. We validated, we needed around 1,000 writes per second. We can get it at this level if we provision 10,000 RUs per second. But what if we need to scale? Okay. The good news about Cosmos DB is we make it really easy to scale up and scale down based on your application requirements. Maybe today I only have 1,000 vehicles on the road, but in a few weeks or maybe months or even a year, business might be booming and we want to scale up. And unlike other database services where you basically have to upgrade to the next tier or buy a bigger, better machine if you're maybe deploying this on your own environment, we can just scale up, let's say 5x, change the throughput here, hit save. It's going to take effect instantaneously. And now if I run the same bulk import, I should be able to get to see a lot higher performance. So here already, right? Instead of the same, for the same amount of writes per second, the same batch document size, I was able to get around 50,000 RUs and basically increase my throughput writes per second by about 5x. All right, so this is just how easy it is to scale Cosmos DB up and down based on the patterns of your database. Okay. Okay, so the next topic I want to cover is partitioning. Remember in that box it asked me what is the partition key? So the question is, why did Cosmos DB ask me for a partition key? And the answer is because it's key to scaling. Okay, there was going to be a sound effect there, but it didn't play. All right, so it's key to scaling. What the Cosmos DB does is instead of having one large and very kind of single point machine that you need to keep scaling up if you need to scale your application, we actually distribute your data among multiple machines. All your data is among the smaller number of physical machines, and each machine or partition, physical partition, is responsible for a subset of the data. So a bunch of data split among horizontally sharded on various machines. Now, the analogy I like to use is if you're working in a team. If you work in a team, let's say you have 5 people, and there's 10 tasks. In an even kind of nice world, each person would get around 2 tasks to do, and you'd get an even distribution of the work, as well as the overall throughput of your team will be pretty reliable, because everyone can do 2 tasks in some amount of time. But if you had a really uneven scenario where one person got all 10 tasks, and the other 4 people were just sitting there, then it's basically unbalanced, and your performance in throughput is going to suffer. So in the same way for partitioning, in general, you want to pick a good partition key that evenly distributes your request volume as well as your storage. Okay. All right. So just to peel back the scenes a little bit to what's actually happening behind the scenes, in this box, or in all these magic boxes, each of these purple boxes is a physical partition where Cosmos DB stores your data. Each of these blue boxes is a logical partition. So logical partition just means any kind of data with the same partition key value is in the same logical partition. So if we took everyone in this room and we made a database of Ignite attendees and partitioned it by our company name, then anyone who worked for Microsoft would be in the Microsoft logical partition. Anyone who worked in the, I'm trying to think of another company name. Joe's Pizza company name would be in their own partition, and et cetera. So in our case, for IoT data, if we partition by something like vehicle ID number, then any vehicle ID with, let's say, 123 is going to live in all the partitions, in the same partition as the other data with 123. New document comes in. Let's say XYZ, it'll get hashed to a range. The range will match this partition, and then data will live there. Okay, so already looking at this picture, we can already see some best practices that we can kind of reason about. The first one is that if we want to push data to Cosmos DB at a super high rate, behind the scenes, we're hashing the value and putting it on a partition. So for getting a high rate of ingest, we'll want to have a high cardinality of data, of data values for the partition key. So vehicle ID number is good because there's a lot of distinct values. We could even increase the cardinality by taking vehicle ID number and do _date or the hour, get even more variety there. So it'll all get kind of evenly spread out among all of these partitions. Okay. The other thing to know is that the RUs of your collection are evenly distributed among all the physical partitions. So when you start out, we provision a reasonable number of physical partitions based on the RUs that you need. So if we have 10,000 vehicles, we're not going to have 10,000 physical machines. We might have 10,000 logical partitions, but we'll start out with a smaller number of physical machines based on your storage and RUs that you provision. So the RUs are distributed evenly among all the partitions, which means that if I keep writing to the same partition, I'm going to get bottlenecked, right? And then my overall throughput is going to suffer. So which is why it's really important for write-heavy scenarios. You want to be able to have a high cardinality of values and then write them all to Cosmos DB at a high rate. So that's for write-heavy scenarios. For read-heavy scenarios, if you're writing queries, the most efficient kind of query I can do here is if you tell us what the partition key value is, then Cosmos DB can route it straight to that partition without having to check out the other ones. So if I want to do a query that's get me all the data for this vehicle, if I know the partition key value of the VIN is ABC123, I can completely ignore the other partitions, which both saves time as well as RU cost to do work on each one of those. Okay. Like I said. So let's actually go ahead and see a demo of this in practice and why it's really important to pick a good partitioning key. So quiz for the room. We told you we're going to write a bunch of data to Cosmos DB all at once. And we need to pick a partition key, and we need to pick some values. Right? So let's go ahead and pick one partition key, which, spoiler alert, I'll tell you will not be a good partition key. I'm going to posit to you that the worst partition key I can pick for this IoT write-intensive scenario is to partition by date. And the reason is if I partition by date, what's today's date? Okay, November 6th. All the cars on the road, if they write data, what's their date? November 6th. So they're all going to hash the same value and all land on the same machine. And then tomorrow, when the date increments, we're going to get a new hot partition and so on. So even if we have 50,000 RUs of throughput, if I run, let's run scenario 2 here. I'm going to partition by date and try to do that same bulk upload. Even though I have 50,000 RUs per second, it's all going to get bottlenecked on that one partition. So in practice, it's going to take a while, and I'm going to see a lot lower throughput. Okay, see, it's already spinning here on stage. It's behind the scenes, it's probably getting throttled, and now it actually took nowhere close. We didn't get anywhere close to the throughput we had provisioned for that we expected, because we're getting bottlenecked on that date. Now, to stop this, and now posit that if we pick a better partition key, let's say vehicle ID number or vehicle ID underscore date, which has a high number of distinct values, for the same throughput, 50,000 RUs per second, we should expect to see this at a much higher rate. So this is the performance we're seeing before in my first container where I was partitioning by vehicle ID number. Okay, so you kind of see how partitioning is really key to figuring out the scalability of your service for both read and write-heavy scenarios. By the way, if you want to get more deep into this topic, I have a colleague on Friday who's giving a talk, so please check that out at the end. Okay. Okay, so we've covered data modeling. We covered partitioning. We've covered RUs. And now, in the last bit of time, let's actually go through some tips and tricks of how you can actually debug problems that might be happening when you're developing, and then also monitor Cosmos DB in production. Okay, Visual Studio is still showing good. Okay. So let's actually go help out a friend here. And the friend here has an application where they have a bunch of data that looks like this. So they've got some items. It's about product reviews. So maybe in a shipping company, people end up reviewing the packages after they get them at the end. Some reviews, and they're just running into problems as they're debugging and developing with Cosmos DB. Let's go through some common scenarios you might run into and see how we can help you out. Okay, so the first common kind of question or query we get is, why is my query taking so long, and what can I do to make it go faster? So anyone run into that scenario when you're like any application, like why is it taking so long? Yeah, so there's a couple things you want to check. In this case, I'm going to run a sample query that just get me all the data for a particular user in my container, print out how long it takes, and it's already kind of taking a while. See if it finishes. Okay, it's taking a while. It finally finished, took around 16 seconds, consumed around 121 RUs. So what's the first thing you want to check if you see something is taking this long? What would you check first? Okay, partitioning key. That's awesome. Okay, actually, I'd say there's actually something that's a little even more basic we should check first, which is make sure that your client and Cosmos DB are in the same region. Sounds very basic, but if they're not, you can see latencies that you don't expect. So in our SDK, we make it super easy for you to actually specify in your Cosmos DB client setup which application which region your application is in, and then we'll direct all your operations to that region for the best performance. And of course, I have a VM here running in Azure, and it's in East US, which is basically where we are on this side of the country. So I noticed that I've actually set my application region to West US. So if I set it to East US, okay, there. Now I finished very quickly, less than about 2 seconds or so. So make sure in when you're starting out, always set your application region to wherever your app is in. This is our .NET SDK, but the similar concept applies to our JavaScript, Python, and Java SDKs as well. Okay, so we ran this app. We got the latency down, but we're still consuming a lot of RUs. We're getting around 881 results for 123 RUs, and we want to see if we can optimize it or make it go faster. So the next thing you want to check is indeed the partitioning strategy. Right? So here, what is my query is filtering on username. So if I wanted to do this query efficiently in Cosmos DB, ideally, what would I filter on? What would my partition key be? Username, exactly. But if I actually go to my demo here and I look at my V1, so V1 is always the bad one, right? V1, I'm actually partitioning by ID, which means instead of making an efficient query to one partition, I'm actually doing a cross-partition query over all the partitions to serve this query, which could explain why the RUs are so high. So if I instead run the same query against my container here, partitioned by username. Okay. So ran it here. This is what we just ran. V1, V2. Now this is consuming 62 RUs. So almost 60 of these RUs, or half of it, was just spent doing the cross-partition query work. So in this case, we're actually able to save a lot of costs by making sure that we pick the right partition key. Okay. Next thing I want to show you is how to use queries versus point reads. So in Cosmos DB, we have a concept of a point read or key value lookups. In general, if your application can do key value lookups, use them. If they're less than 1 KB, they'll all fall in the less than 10 millisecond read and write latency SLA that we offer. So for many operations, you can actually do them via both either a query or a point read. So if you end up doing a query that gets exactly one result that you could have done via key value. So say I look for a username where the type is user, and I get one result back, that's fine. It consumes around 3 RUs, versus if I were to do the same read item async of it, it would just consume 1 RU for that 1 KB document. So if I had 1,000 RUs per second, I could get 3x the number of query operations per second by using point reads over queries. Okay. Next thing I want to show is some settings you should definitely tune on your client-side setup. In V3, in the latest versions of the SDKs, every setting I'm going to show you is already default, so you actually don't even have to worry about it. But for the majority of customers who are on older versions of our client libraries, then this will be very helpful because you want to tune these parameters for best performance. The first thing I want to show you is tuning max item count per page. So when you run a query, we paginate the results and give you a certain number of results per page. By default, in older versions of our library, we'll give you 100 results per page. So every page streams in, that's fine. But it might not always give you the best performance if you just want to get all your results in one page. So what I'm doing here is I run my query twice, where the first one I set it to basically max item count per page of 5. So I'm 50. So each time I'm getting another 50 results. And you can see I'm actually consuming around 86 RUs due to the amount of time it takes for Cosmos DB to keep track of where I am and return the data in pages. In contrast, if I set it to -1, then I can see that Cosmos DB picked a good setting and actually just returned all my results in one page, which also minimizes the number of RUs. So in general, you should tune the setting for what your application needs. If you need a bunch of data to come back at once, tune your page size to be high. Max is either 1,000 or max 2 MB. Or if you only need a few results, tune it to be really small, like 10 or something like that. Okay. Next setting that you want to tune is the max degree of parallelism. So if you end up doing a query that has to go across multiple partitions, it's much better and faster for them to query all the partitions in parallel than going one at a time. So if I run this one, so if I want a high degree of parallelism, set it to -1. Cosmos DB will figure out how many partitions you have, and your client library will query them all in parallel. But if you set it to 0, which is actually the default in our older versions of SDK, you might be stuck waiting a while, wondering, why is it taking so long for me to get all the results? So here's the one where I did a query. This one, concurrency is 0. So you can see it's actually taking a lot longer to get each page of results. All right, so if you're using our client libraries, definitely tune max degree of parallelism and max item count in your application. You can actually get a lot of client-side improvements based off these. Okay, the next thing I want to show you now is we've kind of talked through some tips and tricks for optimizing for reads, but what about for writes? Earlier, I heard someone mention indexing policy. By default, Cosmos DB indexes everything in your data, but you might not want that. if you never query on some properties, it's actually kind of a waste of storage to just have them indexed. And it also consumes more RUs to index it. So what I'm going to do is I'm going to take a document. Okay. A document is going to look something like this. Okay. A document has a bunch of properties that I don't want indexed. And I'm going to write the same document to the two containers, one that has the default indexing policy where we index everything, and one that explicitly sets we only want to index 3 different properties. So these are my default and 2 indexing policy containers here. And if I write the same document to each one, by default, when it writes everything, consumed 25 RUs, but when I tune the indexing policy, it only consumed 12 RUs. So in that way, you can actually get a lot of performance gains by tuning the indexing to explicitly include or exclude things that you don't care about for your write path. For reads, won't really help you since we index everything by default anyway. So at best, you'll have the same performance, or if you try to query something that you don't have indexed, then it can only get worse from there. But definitely tune this for writes. Okay. All right, so we've covered some client-side optimizations. Now let's spend the last bit of time talking about how can we actually monitor and track how Cosmos DB is doing in production. So Cosmos DB has a nice feature where we actually get a lot of telemetry for you in diagnostic settings. Here's diagnostic settings. And we emit a bunch of telemetry, and you can decide if you want to push it to somewhere like a storage account, log analytics, and which particular data you want, as well as the retention on all of these. So all of these are going to be stored outside of Cosmos DB, but Cosmos DB will do the hard work of generating the telemetry for you. All right, so then here, if you go to your log analytics workspace, which you can get to either from just the Azure portal, or you can even just go to the monitoring section here. You can also go to logs here. Okay. I can run a bunch of queries against the telemetry and answer questions like, are there any requests that are getting throttled or rate limited, and how should I actually debug them, or which queries are consuming a lot of RUs? So the first query I have here is checking how many 429s is the status code for throttling. How many requests are getting throttled by Cosmos DB, and which database and container are they happening in? So I can run this one. Looks like I have a few of them. Oh, this one looks like the worst one. I've got events partitioned by date, right? This is probably the one we just ran. We got a lot of throttles. And now the good thing is because you know what the collection is, you can actually then go back to the Cosmos DB metrics here, filter in the storage tab. So I got through metrics, storage, filter to my container, and actually click on a point in time and see what's going on at that point in time. So if I'm going to click on, let's say, one of these. So if I click on one of these points, I could actually see, what are the partition key values that are taking up space, and then click on them and see what the values were. In addition, if I go to, if I go to my storage statistics, I can also see my distribution of storage. So here I see I have a bunch of partitions where this one has a lot of data for this one particular date. It's pretty skewed, and then every bar here is just me running the same demo on different days of the year. So you can also see if your distribution of throughput as well as your storage is even on our metrics as well. Okay. So that's one operation you might want to run and see, am I getting throttled? Next one you might want to do is just analyze if you have expensive queries. By the way, I have a GitHub repo of all this code, so share it after, and I'll check in all the queries and all the code, and you can run it so you know where to read about all these as well. Other thing we can do is write a query to parse our query runtime statistics and figure out all the queries that took more than 100 RUs of request charge and see what they are, and see are there any queries consuming a lot of high RUs. So we have some that are actually consuming a lot, and we see they're all count queries in this case, right? So if I'm doing a lot of counts, if my application needs that, then maybe I just store that data somewhere in a materialized view so I don't have to keep computing it every single time. Okay. In addition, I see there's other queries. Here's a cross-partition query I ran earlier. I can see the RUs for that one. So this helps me figure out, okay, do I have a good partition key, or are my queries actually taking up a lot of RUs in the wild? The other nice thing is from our SDK, you can actually use our middleware layer to write your own handler to do things like send custom data to app insights. So here I have a custom handler that's it gets run every time I do a request, and I can parse out things like what is the RU charge, what is the activity ID, what is the content as well, like what is the actual name of the query, and I can join between these two things. So if I go to this query, run it. I can actually join, this is what I'm sending, the full text of the query. We don't log your full text for PII reasons, but we can if you want to file a support ticket. Join the full text of the query against the RU charge. So I can see this might give me a good place to start debugging where to go on. OK. Okay. Okay. All right. So what we've covered here is some of the kind of how to get started, what to think about, highlighted some of the concepts you'll need to worry about on partitioning, on some client-side optimizations you can do, as well as how to actually monitor Cosmos DB in production. So let me share this again. Oh, it's not up. OK, sorry about that. You know what it is? I closed the X and actually closed the PowerPoint slide deck instead of the slideshow. If you're presenting in the next couple of days, let my mistake help you out. OK, what is it? Control F5. OK, slideshow. Oh, OK. OK, last things you want to do, you'll want to probably add a second region to get higher availability. And if you have if you have 2 regions, you'll get 5 nines of read and write availability. If you only have 1 region, you'll get 4 nines, which is still OK, around 52 minutes a year. But for really critical workloads, you'll want your 5 nines of the second region. So what we've covered here is we talked a little bit about how to set up the service, some client-side optimizations you can do, how to do some benchmarking, how to actually use our logs, telemetry, find expensive operations, diagnostics, log, and metrics, and then also highlighted some other topics that you'll want to think about. So if you're more interested in kind of the event-driven nature of Cosmos DB, we have a ton of other sessions are interested in more of how to get high availability with Cosmos DB, we've got a session on that. More detail on data modeling and partitioning. What do I actually put in my JSONs? Go to there. And if you actually use a MongoDB if you're a MongoDB developer, you can go to our Mongo session as well. All the code I showed is up here on my repo, so please go check it out after. I'll check in all the queries and things so you can run them on your own time as well. Cool. All right. Thank you so much for coming to this.